Assalamualaikum warahmatullahi wabarakatuh. Hi guys, let me introduce myself. My name is Nurnita Khairun Putri. I'm a college student of Mathematics Study program at Padang State University. In this video, I will explain about the history of derivative, basic idea of derivative, example, and application of derivative. Please enjoy watching. History of derivative. Since derivation is a branch of differential calculus, the history of its development is also closely related to the development of calculus. The concept of derivation was conceived at the same time by Sir Isaac Newton, the English mathematician and physicist, and Gottfried Wilhelm Leibniz, the German mathematician. History records that calculus was developed first in Egypt, Greece, China, India, Iraq, Persia, and Japan, but the use of modern calculus began in Europe in the 7th century when Isaac Newton and Gottfried Wilhelm Leibniz developed the basic principle of calculus. Their work then has a strong influence on the development of physics. In line with the development of modern science, application of calculus, in particular to differential, include calculation of speed and acceleration, the slope of a curve, and optimization. Basic idea of derivative. Derivative in mathematician, the rate of change of a function with respect to a variable. Derivatives are fundamental to the solution of problems in calculus and differential equation. The derivative of the continuous function y equals fx is the rate at which the y value changes with the x value. If the change in the x value is h, then we can write f in the bracket x plus h close bracket minus fx all over h. As a result of this change as shown below, you can see in this picture. If the value of h is taken small, close to 0 or limit h approach 0, then the change will be the rate of change. This is the basis of derivative concept, so that the derivative of the function fx denoted by f prime x is defined as f prime x equals to lim f in bracket x plus h close bracket minus fx over h as h approach 0. So, the derivative notation of the function y equals fx can be written as y prime or f prime x or dy over dx or df over dx. Based on the definition of the derivative above, we can get separate rules for getting the basic formula for the derivative of an algebra function, namely, if fx equals to ax to the power of n, then f prime x equals to n times ax to the power n minus 1. The development of this formula is the derivative of the form fx equal ax and the form fx equals c, where c is a constant, which is was follow 1. If fx equals ax, then f prime x equals a. If fx equals a, then f prime x equals 0. Example. Find the first derivative of the function fx equals x cubed minus 2x squared plus 3x. Answer. F prime x equals 3 times 1 times x cubed minus 1 minus 2 times 2x squared minus 1 plus 1 times 3 times x to the power 1 minus 1. F prime x equals 3x squared minus 4x plus 3. Application of derivative. Derivative has many applications in the quantitative field. One of them is Newton's law of motion, which states that the derivative of the momentum of an object is the same as the force exerted on the object. The rate of derivation is also a chemical reaction, is also a derivative. Derivative has various important applications in mathematics, such as 1. Rate of change of a quantity. 2. Increasing and decreasing function. 3. Tangent and normal to a curve. 4. Minimum and maximum value. 5. Newton's method. And 6. Linear approximation. In real life, derivatives are used in various fields, including in medicine for the modeling cancer, growth, or the spread of disease; in engineering for describing the movement of electricity; in chemistry for modeling chemical reaction; in economics to find optimum investment strategies; in physics to describe the motion of waves, pendulums, or chaotic systems. With such ability of describe the real world, being able to solve differential equation is an important skill for mathematicians. That's all for me. More and less I'm sorry. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.